In this video, we're going to look at graphing the function of the absolute value of x as opposed to the absolute value of function x. So in a previous video, this is what we've graphed. And there is an example on that. Okay, so where the f of x is inside the absolute value. This time around, the absolute value is enveloping the x itself, not the function. So as an example, so if we had, for example, let's say f of x is equal to x squared plus 3x, the f of the absolute value of x means that we're replacing all the terms in x with the absolute value of x. So absolute value of x squared plus 3 times the absolute value of x. So algebraically, that's in fact what's going on. So, but let's have a look at it in terms of a graph of function x, and let's have a look at it geometrically. So what's going on here is that all the negative values of x, okay, the absolute value is going to be taken of the negative values of x, they're going to turn positive again, and it's like you're taking f of x when x is in fact positive. So what does this mean geometrically? So that means then that when x is positive, f of absolute value of x means that there's no change. So this part of the graph is retained. So in fact, I might actually draw it in. Okay. So that's in red there. But then what happens then to the left of the y-axis? So this is quadrants 2 and 3. So what happens is that the original graph is ignored completely, in fact. And so what ends up happening is that, let's say you chose a value of x, I don't know, let's say here, okay? So let's assume that's say -1 or -2, let's say -1. The absolute value of -1 is in fact 1. What's the y value when x equals 1? And then that's going to be reflected back this way. So I'm going to try and do this as neatly as I can and as accurately as I can, of course. But what's going to happen is that this part of the graph here in quadrant 1, or in fact quadrants 1 and 4, is going to be reflected this way in the y-axis, sorry. So this part here in red, okay, we identify that, that's going to be then reflected, okay, in the y-axis. So it's going to look something like, if I maybe put a few points there, arrow goes back up there. So it's going to look something like, there's going to be a sharp corner here as well. It's going to rise again. Probably do something like that, okay? So this part of the graph here in quadrant 2 is a reflection of quadrant 1, and if there's anything here in quadrant 4, that'll be reflected back into quadrant 3. But this part of the graph here, so of the original graph in quadrants 2 and 3, is ignored completely. So this graph is the graph of y equals f of absolute value of x. What you'll notice as well is that it will produce an even function. Okay, so it'll have symmetry in the y-axis. Okay, so which is even. Okay, the other point to note here is there's a sharp corner here. Okay, so there's a sharp corner. Okay, so I'll just write that a bit neater. Okay, there's a sharp corner there. So is this function smooth? Okay, which is even, but not always smooth. There are some rare functions, there's a few examples of functions where even if you took the absolute value, the graph is still smooth. And if you take a horizontal line, for example, that would be an example of a smooth curve, where if you took the absolute value of it, or whether it's the function itself or the absolute value of x itself, well, the reflection is still going to be a straight line, a horizontal line, and it's still smooth. So for the most part though, y equals f of absolute value of x will produce an even function and will have a sharp corner. So just be mindful of that. Thanks for watching and wishing you all the best for your studies.